Okay, this week we're going to be covering Chapter 9. So the schedule's a little different this week. My father's having a surgical procedure. I'm going to be out of town. I'm still going to be available, but the times that I can meet is going to be a little bit different this week. Okay, so if you have questions, still email me as always. Um, but we'll have our class meeting this week, our Zoom meeting, just on Tuesday at 8 o'clock. Okay, rather than the Tuesday and Thursday. That's just this week, as far as I know. Next week should be back to normal. Okay. Also expect the quality of video to potentially be less like it was when I was visiting there before, because the internet's not as good and I don't have as good a setup and all that. But anyway, we'll make it through. Okay. The other thing I want to talk about this week is the midterm exam, some irregularities that have popped up and some things that we need to talk about. Okay. First, let me say, if you're the paranoid type of student like I always was, if there was an issue with your midterm, and there were issues with some, we've had a conversation about it already. I've sent email, you've responded. So there are no surprises. So if you haven't heard, I'm not talking about you. Okay. I know I would have been paranoid. So the issues come down to a couple of things. Okay. The first issue was the one of the time limit of the exam. So the exam was a 3-hour exam. It was pretty clear. It was on the test. We talked about it in some of the videos. That you had 3 hours. I talked about the rationale for that. I know some of the other classes apparently, in talking to Heather, that the CTE don't use timed exams. I know that there are difficulties in finding 3 hours in a row to do that. That's why you had the entire weekend to take care of the exam. I didn't hear any complaints about that, the timing. If there are issues, let me know. The final is going to be very similar. It's possible that I can divide it up on the final into 3 separate tests of 1 hour each, where each one you do a problem. If that's helpful, let me know. Okay. But the time limit was not optional. Okay. It was not a recommendation. It was done because, given enough time, if you have Google, even if you haven't been working along and haven't learned much, you would be able to find answers to the solutions. Okay. So I think the time portion is important. This is a skill-based class, and that's what I'm trying to get across. Okay. Someone took the exam during the normal time. First, let me say, back up a second. There were some students who got to the end and went to upload their last file, and there was an issue. Either it didn't tell them they were about to time out, or by the time their internet was slow, by the time they got it uploaded and all that stuff, it wouldn't let them do it. Okay. Those students, and I think every student in that situation did the correct thing. They immediately sent me an email, and they sent me a copy of the program that they were trying to upload. Okay. I could tell from Moodle when they started. I can tell they were sending me the file right after that 3-hour time limit had eclipsed. Okay. So there's no problem. I graded it and gave them full credit, and there's no issue. Going into the final, know that Moodle does not give you any warning. So hopefully we won't have to do that again. But if we run into that situation, then that's what you do. Send me an email right away with the file. Don't take 10 minutes to mess around. Do it right away, and we should be okay. The problem issue was somebody submitted their files much later. 2 of the programs like 3-4 hours later. Okay. And were expecting me to grade them and just pretend like it was all okay. Well, it's not okay. I didn't grade them at all. That is outside of the bounds of the exam. Okay. So, and that's how it's going to be in any class you take, pretty much. If there's a time limit, there's a time limit. Okay. And I will make reasonable accommodations, but 3 hours is not reasonable. Okay. As a side note, the person also sent a couple of pretty angry emails. That's never a good idea. Okay. I did not respond in kind. I try to maintain a professional atmosphere. That's what we all should do. If you're angry at something, don't send an email. No good comes from that. Okay. And I'm not going to continue to have conversations that are ugly. That's just not how it works. Okay. If there's not respect, then one of us needs to go. It's probably not going to be me that needs to go. Okay. So I think we can move forward. No one has burned permanent bridges on this. It didn't get that bad, but just as a warning, I think most of us are not going to have an issue with that. But sometimes we get upset. We get hostile about something when we think we've been wronged in some way. And it's not to say that I can't make mistakes. In this case, I don't think that I did. It was clear that we had 3 hours and taking more was not an option. And again, if there's a particular issue, you can talk to me in advance, but you can't day of just turn stuff in late. Not going to work. Okay. So hopefully that's not going to be an issue going forward. Because again, the final will have the same basic parameters. I think most people completed it on time. When you exclude the problem tests, then I think the class average is like an 84, which is good. And further, the students who seem to be doing well, seem to be doing homework well and on time, they made A's, and they were at least a couple of hundreds. So I don't think the material is beyond the grasp of folks. But I don't know. We'll see. If you have particular issues, let me know. Just keep it professional, and we'll move forward. Okay. The other potentially more serious, although they're both serious issues, had to do with a potential honor court violation. As you may or may not know, the UVA has a very strong honors policy that you're not supposed to help or receive help on any assignment. They take it seriously. If you're caught to have a violation of the honor code, it goes to an honors court, which is made up of faculty, staff, and student representatives, and they can impose sanctions all the way from you fail the course to you're kicked out of the program and of the school forever. It's a big deal. Okay, so as a faculty member, if there's a clear case of plagiarism or turning in work that's not your own, I am duty bound. I'm contractually bound to turn it in. So it's a big deal. Okay. And I think the issue on this first test, that the folks that had issues with this, in one case, I think it was a mistake, didn't mean to upload the file that they did. I mean, that's a possibility. So let's talk about the issues there. What can you do on the exam? You can Google whatever you want. That's fine. I'm used to giving tests in the classroom where we don't have that option, but it's online. I can't stop you. I can't rely on the honest people not Googling and the dishonest ones getting an advantage. So everybody can Google. Okay. What you can't do is turn in somebody else's program in whole. And that's what some students did. They had their name at the top in the comment block, and then they had a program that I quickly and easily determined was not theirs, found it online in no time with Google, that didn't really solve the problem that I'd asked for. Okay. So if that is done in error, then it means that your techniques are not correct. It's better to get a 0 because you don't know what's going on than it is to attempt to pull a fast one and try to get some points, even though it doesn't really solve the problem, and have a potential honor court violation. Okay. So if it were me, what I would do, I would never, ever, ever bring up a program that's not my own into Eclipse. I would never have it in the same place. I would make sure it was named something entirely different from what it is I'm trying to do. And I would especially never put my name on that code in the comment block. Okay. If you're thinking it's a good idea, oh, I will download this example of a class file or whatever that's similar to what I'm doing, then I'm just going to change things. Bad idea. You're playing with fire. Okay. Because you may not change everything. Much better to have that example up on one window while you're working another, or print it out, or do whatever you have to do. Okay. I know I warned you, because students that had this issue said that I had said this, that you can go down a rabbit hole on online help and get yourself into trouble that way. And you certainly can. It's much, if you're having to look up a whole program to try to model yours on, you're probably in trouble anyway. Okay. Better to look for an example. You can Google, how do I instantiate a class? How do I write an accessor program in Java? Those kinds of things where you get examples on the screen, you type in your code to match the problem, looking at the example. All that makes sense. Okay. So the other thing that I'm sure I mentioned at the first of class, if you're using code you found on the internet in part, you have to first understand it. In every example where someone turned in suspicious code that I found online, it was using libraries we haven't talked about. It was using techniques we haven't done before. It was naming variables in ways that we haven't done. Okay, so it's a pretty clear giveaway most of the time. Okay, it's also unlikely if you struggle on the first two problems that you're going to throw out a perfect third program that does more than I ask for. Okay, that's just suspicious. It's not going to work that way. Okay, so if you have questions about any of that, let me know. Okay, but moving forward, we are going to we're going to have to make sure that we're doing our own work. It's okay that we look for examples, but we need to type in all the characters we're doing. We need to understand what those do. If you're going to do things we haven't talked about in class, which is okay in some cases, it's usually not a good idea because there's a reason we're doing it the slower, less efficient way. Then that's one thing, but you just want to be careful there. Okay. An honor court violation is not something to mess with, and I don't have a lot of discretion when it comes to reporting those. Okay. So anyway, enough about that stuff. So let's talk about the new material this week. Okay. So we're doing chapter 9, which is all on inheritance. Okay. Inheritance is a very powerful tool. Okay. And it allows us to create a lot of functionality pretty quickly. Okay, so I'm going to go ahead and share the whiteboard here. Okay, so the inheritance, we've talked before, just to go back to I think it was last chapter, the composition. And we talk about that as a has relationship. Okay, so if you define a date class, we usually do class names with a capital. If you define a date class, then that date class could be some of the member data on some other class. Okay, you could have a date, hire date, whatever it is. Okay, so that's a has a. An employee has a hire date or has a date. Okay, so that's I don't want the news. I'm not trying to look at the news. I don't like the news. Okay, so that's the has a relationship. Okay, so the next thing we're going to talk about, and this chapter talks about, is the idea of inheritance. So inheritance, instead of a has a relationship, it has an is a relationship. Okay, so we sometimes call this specialization. Okay. Okay, and the book gives an example or some examples on page 375. And again, we're going to call this a superclass and a subclass. So if we have a superclass of student, we could have a subclass of graduate student or undergraduate student and so forth. Okay, so that's the idea. So you have a more general, that's what we call a specialization. The student's a more generic student, and then the graduate student would be a specialization of that. Okay. Another example they give, which is pretty good and pretty complete, is going to be on page 376, and that's figure 9.2 on the university community member hierarchy. Okay, and it starts off with the community member, the most generic. Okay, that's the superclass of everything. It gets specialized, and again, the UML diagram we're going to use for that, there's an open triangle. Okay, we can have an employee, we can have a student, we can have an alumni or an alumnus in this case. Okay, so we're going to have 3 specializations from there. Okay, employees then can get divided up into faculty and staff. And then we can have further subdivisions. Okay, and the point of this, it's going to allow us to make classes more quickly, is that whatever is in the superclass gets passed along to the subclass. So you don't have to start over again, okay? So if you find information that's going to be general to all of these, okay? So all these people are going to have a first name, let's say. They're going to have a last name. They're going to have some ID number, okay? So we're going to put all of this in our superclass. And it means that other classes are going to have access to that. We'll talk about the access in a minute because it can get a little funny how that happens, okay? Methods are the same way. You can have methods that are here that are going to flow down, okay? So at every step down, we're going to be adding either new methods or new member data, okay? If not, then why would you have the specialization, okay? So for example, faculty, so employee, they're not a student, they're not an alumni, so they're going to have a salary, let's say, okay? Faculty could have a department or a academic department or a rank. They could have their academic rank, okay? Where staff wouldn't have that. A staff could have a department, okay? So, and then again, student could have which class, are they freshmen, are they sophomores, are they whatever? What's their major? Okay, that's going to be something that just students have. Okay, and then alumni could have like the degree held, and it could be the degree year. And here you could track, you know, amount given if you're trying to hit up your alumni for money, which they always seem to be doing. Okay, so again, in this hierarchy, we could say that a faculty member is an employee is a community member. Okay, a student is a community member. An alumnus is a community member. Okay, doesn't work the other way around. A community member is not an employee. They could be, but they don't have to be. Okay, we're also saying nothing. And note that employee and student, the class here, there's no way to go up and back down. Okay, so the information or the structure flows down in that all of these will have access to the community member class. Okay. So that's the basic idea we're talking about here. Okay. Now, the kind of access that they get is where it gets a little bit interesting. Okay. So let's go back to our UML diagrams here. And let's say we have our community member. Okay. And it's going to have, let's say, as we normally do, a private first name and a private last name. Okay. Then we're going to come that, we're going to bring this down into an employee class, let's say. Okay. And the employee class again can add salary. Then we had that, a couple down coming off of that. Okay. If we keep these as private, then an employee doesn't have access to first name and last name. Okay. They would have to use the accessors and mutators. And that may be how you want. Okay. So down here you could have, you know, the get first name, for example. Okay. As it stands now, the employee would have to do that if it wanted to get to the first name and the last name. Okay. You could make it public, of course. If you make it public, then not just employee, but any other class anywhere can make changes. And that's not a good idea. Okay. So to deal with this issue, we have the option of making them protected. Okay, protected, we're going to use the hash symbol, the official name is the octothorpe, you call it a pound sign, whatever it is. So our diagrams are going to have that. Protected means that subclasses, derived classes, can get to the first name and last name as if they were part of that class. Okay, so in the tree over here, all these, even staff, if these are both listed as protected, then staff, if I say staff Bob is equal to new staff, which is what I would say. I'm not dealing with the constructor yet. Then I could say Bob dot last name is equal to Smith. And that's okay because it's protected. Okay. So you don't always want that. You sometimes want there to be rules that they have to follow. Okay. But sometimes not. Okay. So the example in the book in section 9.4 goes through a pretty complicated, long drawn out example where it's going to create this commission employee class. Okay. And on page, this is figure 9.4 on page 379, we're going to use this new keyword extends, and that's how we do the inheritance. And it's going to extend object. Okay. Which object you may be asking? Well, everything in Java extends from object. Okay, so when we did the employee class, we did the date class, we did the account class, we could have put extends object in all of those. Okay, but it's the default, so we don't have to put it. They put it in this example just because they wanted to show that, but it doesn't really have to be there. Okay, you can just go like that. We're going to call this the superclass. Okay, and this one's going to have first name, last name, social security number, gross sales, and commission rate. Okay, so that's going to be all the member data that it has. And it starts off making all of these private. Okay, you can see those on page 379. Okay, so it then explains what each of those does. Okay, in addition to that, there's some methods they're doing here. They've got a accessors to get first name, get last name, get social security number. They've got there are no sets for those, by the way. Those are all set just in the constructor and can't be changed. Then there's a set gross sales. Okay, then there's a get gross sales. And then there's a set commission rate and a get commission rate. There's an earnings, and there's a toString that's going to return just a string representation of the current state of things. Okay, so the next thing it's going to give us is a test. So on page 382, there's a test of this commission employee class. Okay, so again, we're going to have line 6 on page 383, commission employee employees equal to new commission employee. We're going to send it the parameters for the constructor, first name, last name, social security number, commission or gross sales, and commission rate. Okay. Once we've done that, then we're going to go through and test those. That's all we're doing there. Okay. So the next thing they do in section 9.4.2 is not using inheritance. It's kind of the way we would have done it if we didn't know about inheritance. And that's this base plus commission employee class. Okay. So this base plus commission employee class is going to be a whole new class that doesn't have anything at all to do with the commission employee class. We're doing it all over again. So again, we're going to have the private string first name, last name, social security number, gross sales, commission. Well, all we're adding to it's the base salary. Okay. So this is an example where we're not using inheritance. Okay. So that's a big long example they give you just to show you the pain of not using inheritance. Okay. Then they test that as well. Okay. Then they're going to go back and say, well, if you look at those two sets of code, much of the code's exactly the same. All the stuff about getting the first name, getting the last name, social security number, all that. All that was different from was the base salary. Okay. So that's going to get us to this base plus commission employee.java, which is it's a subclass of the superclass commission employee. Okay. Probably makes the most sense to pop this up in Eclipse, and we'll type some of the salient stuff in there. So this is not going to work, so I'm not taking the time to type in the superclass, which I should. Okay, but and this one I'm going to call this one what? Base plus commission employee. Okay. It's got the public static void main. Note that we have options we haven't used before here. we have whether or not we want to get the constructors from the superclass. Okay, we're going to talk about calling the superclass constructors, and that makes more sense. If not, when we had the superclass subclass designation, it would just pull a copy, which is probably not the most efficient way to do it. So we'll ignore that for now. We already have the inherited abstract methods there by default, so we'll just leave that there. Okay. And what, I don't know why this keeps sometimes having that, sometimes not. Okay, so we'll go ahead and get this going. And what we want to do different here than what we've done before here, we want to say public class base plus commission employee extends. Okay, that's the key word that's new. It's going to extend the commission employee. Okay. This is going to give me an error because it can't find that. Okay, so if I had typed that in first, we wouldn't be having. See, again, I can go ahead and do create that class right now. I'm just going to deal with those errors. Okay, which means that you would probably get a lot more help in typing this in than I'm going to get, and I'm going to get a lot more errors. Okay, so what we're going to be adding to this, and this didn't need a public static void name. That was wrong. Again, these are classes that we're doing. Okay, so I don't want that. Go away. Go away. Okay. But what I do want to do, okay, so I have already the first name, last name, gross sales, and commission rate from the other one that I didn't do, but it would normally be there. Okay, so what I need to add here is going to be private, a double variable for base salary. Okay. And in this case, it's per week. Important to know that. Okay. Now we're going to look at what the constructor looks like here. So it's base plus commission employee. Okay, all that we would imagine. It's going to take all the stuff that we get in the commission employee, again from the book. I didn't type that in, but you get the idea. So string first name, string last name, string for the social security number, double for gross sales, double for commission rate, and now the new one, double for base salary. Okay, and again, it's going to have issues with a lot of that because we don't have those things. Okay, but assuming that we had that superclass out there. Okay, so what we have to do now, we don't want to recreate the other constructor. Okay, so I'm going to call the constructor of the superclass. I do this with the word super. Okay, the book talks about this. Java, unlike C++ and other languages, only inherits from one other class. So when I say super, it knows that's the direct parent. Everything inherits from object, so we don't really care about that. But we know that commission employee, the super, is going to refer to this commission employee. Okay, the base plus commission employee extends commission employee, so super refers to that. Okay, so we're going to call that constructor with the things that it needs. Okay, which is basically the first name, and again, it's in the book with the other things there. The last name, social security number, the gross sales, and the commission rate. Okay. When we do that, it's going to set up with whatever restrictions that the superclass has, that commission employee has. It's going to create that. It doesn't create a commission employee object. It creates a base plus commission employee object, which is a commission employee object, which gets a little confusing. Okay. So we now have to deal with whatever's extra. Okay, in this case, it's the base salary. So I can have our if base salary is less than 0.0. We're going to throw new illegal argument exception and say base salary must be greater than or equal to 0.0. Okay, so we're just doing that real quick. Okay, I don't know why it doesn't like that. Let's see, could be something else going on. Throw new illegal argument exception. Yeah, I'm not sure what. Yeah, I'm not sure where that may be something from the other class that's doing that. That's really weird. I'm not sure it's why. I don't know why it's doing that. Anyway, you could also just do an error message there if you wanted to, if that becomes an issue. We're doing half programs, so it makes it hard. But if that's not the case, so we've gotten rid of that issue, we can then do this base salary is equal to base salary. Okay. I'm not sure what this one is doing. Where does that line up at? Okay, that ends that. Okay, so this ends is over one then. It's a constructor. This ends the class, so that makes this one extra. Okay, I think that's correct. Okay. So again, basically, we're going to deal with whatever the superclass takes by putting those things in, okay, with the super, and then we'll deal with whatever's extra, okay. If we're dealing with the case where we had a faculty is an employee is a community member, then we would have to call the superclass that would then call the superclass in a cascade, okay. So that's how you deal with those multiple inheritance issues. I mean, multiple lines of inheritance. You can only inherit from one parent, but that was what a grandchild or a great grandchild would do. Okay. And then the other thing we have to do, we have to look at what other methods we need. Okay. And I won't type them in because they're in the book, but basically you're going to have a set base salary. Okay. You're going to have a get base salary. Okay. And then you're going to have to override a couple of the others. Okay. So we do the override of the earnings, and we do an override of the toString, because there's going to be new stuff in there. Okay. So that's how we're going to deal with those issues. Okay. So then it goes through again, as the book always does, and explains all those in more detail. But that's the basic idea. Okay, so a subclass constructor must call the superclass constructor, something that you have to do. Okay. And then the methods earnings and toString have to be changed. Okay. So that's where, let's see. It's going to tell us, yeah, what we're doing there. Okay. Then 944 talks about what would change if we went back and made the member data of the superclass being protected. And this means we wouldn't have to use the same stuff. So there's an example of that as well. Okay. So that's all that. And then the last one is the using the private instance variables, what that would look like. Okay, so you have lots of examples there. Okay. And that's most of what this chapter has to say. Okay. So the last little bit here is going to talk about, this is 9.6. It's just kind of a general section. It's that, again, every class, everything in Java, every class that you create extends object. We don't have to say it, but it does. So there are some methods that we have on object, things such as the toString. Okay. We've also said before that every object knows its length. So that's something we've done before. Okay. And then 9.7 talks about the differences between doing inheritance as opposed to doing composition. Okay. And that's a pretty short section, but you can certainly look through that. Okay. As far as the homework for this time, in general, the homework is going to be, as we go forward, fewer problems, but each one's a little more complicated. Okay. So this week, it's just going to be 9.14 and 9.15. So in 9.14, you're going to create a superclass above the commissioned employee called employee and move some stuff around on that. Okay. And then in 9.15, you're going to create a salaried employee that will be a sibling to the commissioned employee class. Okay. And it's going to go through those. And that will be, those two will be good practice on how we're doing these classes. Okay. Okay, so that's it for this week. Just to reiterate, all this will be on Moodle, and I'll put the homework assignment up right now. We're going to meet Tuesday at 8 this week. That'll be only meeting this week. But as always, send me an email. We'll figure stuff out. We'll probably also post, homework was due last night. I usually give you a day or two extra. So if you don't have it done yet, go ahead and get it in by tomorrow. And then tomorrow evening, I will try to put out a homework solution video, a real quick one, just to see what you could have done differently on those. Okay. If not, I think that's it. Okay. So if you can, I'll put up a forum as well for questions. Make sure you ask questions there as well. That way other students can answer them and not just me. Okay. Okay. So I'll see those of you who can make it on Tuesday at 8.